All right, so let's go ahead and practice bringing a matrix down to first echelon form and then reduced echelon form. And the way we're going to do that is through row operations, which we saw a couple videos back. If you forget those, they're pretty simple. There's three things that you can do. You can replace rows, which is the most commonly used row operation. You can interchange rows, which is kind of exchanging rows. So it's declaring that what is row 1 is now going to become row 2 and just kind of flipping them like this, right? And then scaling, pretty straightforward. That would be something like, oh, well, I'll just divide row 3 by 3 since I can see a common denominator there. Or we could also, divide row 2 by 2, okay? So when you're doing row reduction and when you're getting a matrix down to echelon form and reduced echelon form, I always encourage people to start from the left, okay? Start here and work your way down first. And then once you get this first column down, then just work your way to the right. This part of linear algebra isn't hard, but it's very error prone. You will be surprised how many times you say, oh, I don't know, 2 plus 5 is 10 on accident just because you're going so fast. How it's funny how trivial, addition, subtraction, multiplication, and division are, but they're really easy to mess up within context of row reduction. So start with the first column and work your way all the way down. Get zeros in the entire column, then move to the next column, okay? So let's go ahead and start that. I'm going to clean this up a little bit, and we'll go ahead and start. So essentially what row reduction is going to do and what row operations are, we're going to get this down to echelon form. And we're going to do this first by replacement. And again, this is kind of your most used one. And basically what we're saying is we're going to do something to a row, and then we're going to put that, we're going to combine it with another row somehow, maybe row 2, and it's going to go into row 2, that result. So you'll see this kind of notation a lot, and it's really handy to use that notation. Let's go ahead and do it. So if I'm trying to make this entry here a 0, what I want to see is that, okay, well, this first entry, this 2, is 2 times my 1 in the first column, first row. So if I were to multiply row 1 by -2 and add it to row 2, that would make this 2 a 0, okay? And I always recommend doing it in this format where you're taking a row and adding it. Adding it is huge. So that means that you're going to be multiplying by a negative. So let's look at that. So -2 times row 1 plus, always important to add it. It just makes things a lot easier. Plus row 2 into row 2. And what happens if we do that? So now A is going to be reduced. Whenever you're doing row replacement, whatever row you're multiplying, in this case row 1, stays the same. And whatever your result is goes into your new one. So we know -2 times 1 is -2, plus 2 is 0. -2 times 2 is -4, plus 4 is 0. -2 times 4 plus 6 is -2, because -2 times 4 is -8, plus 6 is equal to -2, right? So we have -2 there. So we've just replaced, okay, row 2 using a combination of row 1 and row 2, all right? And whatever rows you're not using in your replacement also stay the same. So these are going to be the same just like that. Now what we have to do is we have to work with and get rid of the 3 in row 3, right? Column 1. Remember, echelon form is when you have leading entries in a column and everything below the leading entries are zeros. Okay, so we need to make this 3 a 0. And how are we going to do that? We're going to do it in a very similar manner than we just did with row 2. And that's by saying, okay, well, let's do -3 times row 1 plus row 3, and we're going to go into row 3. And what's that going to leave us with? Well, again, when we do row replacements, whatever row we're kind of whatever row we're working with, or multiplying in this case, row 1 is going to stay the same. Any row we don't mess with is also going to stay the same. And that final row that we're getting a new value put into is going to be what changes. So if we multiply 1 by -3, that's going to be -3, and we add that to 3, we have 0. If we multiply -3 by 2, okay, then we're going to get -6, and we're going to add -6 to 6, we're going to get 0. If we say -3 times 4, then we have -12. -12 plus 9 is -3, okay? So now let's look at a couple things. So we have zeros right here, which is nice. So this is a leading entry. This one is a leading entry. We also have zeros right here, right? Well, no leading entry can be in the same row as another leading entry. So we have to go down to the next row to find our next leading entry. And what do we see? We have a leading entry here now. So our next step is to get rid of this 3, that -3. That's going to get us into echelon form. So this is where scaling becomes very handy, because what we can do is we can scale both of these columns, or both of these rows, excuse me, by 2 separate values. And we'll go ahead and make them 1, because it'll just make it a little easier. So we're going to divide row 2 by -2, and we're going to divide row 3 by -3. And what's that going to leave us with? That's going to leave us with everything staying the same as we had before. But now this -2 is going to become a 1, right? We're dividing the entire row by -2. So 0 divided by -2 is 0 still, right? Again, 0 still. -2 divided by -2 is 1. Same idea with the third row. That's going to leave us here. And then finally, how are we going to get this to echelon form? We're going to do what we were doing before, and that's a replacement. And we'll just say this time row 2 plus row 3 into row 3. And that's going to leave us with, and you'll commonly see this in textbooks and in different note sheets and things like that. Instead of kind of continuing on A equals something, right? You'll see this. They'll just say a little squiggly line, and that's just saying, oh, this matrix is being simplified a little bit. So what is that going to leave us with? Obviously, we're staying the same in the row that we're manipulating. If we say -1 times 0 plus 0, well, that's 0. -1 times 0 is 0 plus 0, that's still 0. -1 times 1 is -1 plus 1 becomes 0. And now you can see we are in echelon form, because we have leading entries, okay, with zeros beneath them right here and right here, okay, and each leading entry in one row, in one column, is above leading entries in a column to the right of it, right? So we can see where we have this little step down nature with our leading entries, which is what we wanted. Okay. In the next video, we'll go ahead and do how we get from echelon form. We are now finally in echelon form. Echelon form of A. So in the next video, we'll go ahead and go to reduced echelon form.